You just spent 60, 70, maybe $80,000 on an electric vehicle. You pull it into your garage every single night. You plug it in. You feel good about yourself, cleaner energy, lower fuel costs, cutting-edge technology. But here is what nobody told you at the dealership. That vehicle you are so proud of, it may weigh nearly 3 times what your garage slab was engineered to handle. And every single night you park it in that garage, you are loading a structure that was designed decades ago before electric vehicles even existed, with a concentrated mass that the original engineer never accounted for. I am Engr Vance, licensed forensic structural engineer. And today, I'm going to walk you through exactly why your garage slab may be quietly failing beneath your EV, what the building codes actually say about residential floor loading, and what a structural failure in your garage can cost you, not just in repairs, but in a homeowner's insurance claim that gets denied because nobody warned you this was coming. Stay with me. This one is important. Let us start with raw numbers, because the numbers here are genuinely alarming. A standard mid-size gasoline-powered sedan from the early 2000s weighs somewhere between 2,500 and 3,200 pounds. That is what your garage was built around. That is the loading assumption baked into the slab design when your subdivision was originally developed. Now compare that to what people are parking today. A Tesla Model Y tips the scale at 4,360 pounds. A Tesla Model X, the full-size SUV version, comes in at 5,390 pounds. A Rivian R1T electric pickup weighs 5,600 pounds, and the GMC Hummer EV, which is actively being parked in residential garages across this country right now, weighs 9,063 pounds. That is the gross vehicle weight of a medium-duty commercial truck, sitting on your residential garage slab every single night. The question is not if this is a problem. The question is how bad your specific situation already is. Now let us talk about what is actually underneath you when you pull that EV into your garage, because most homeowners have never thought about this for even 60 seconds. A standard residential garage slab in the United States is a slab-on-grade construction. That means a concrete pad poured directly on compacted soil, with no structural support underneath, no beams, no piers, no suspended framing, just concrete sitting on dirt. The International Residential Code, specifically IRC Section R506, governs slab-on-grade construction for 1- and 2-family dwellings. It specifies a minimum slab thickness of 3.5 inches for standard residential applications. Many builders in the 1980s and 1990s poured exactly to that minimum. Some poured even thinner. And the reinforcement? Most residential garage slabs from that era contain either light-welded wire mesh or no reinforcement at all, because the IRC does not mandate steel reinforcement for slab-on-grade in standard residential construction. The load design standard referenced by the IBC and IRC for residential garages is a live load of 50 pounds per square foot per ASA, 722, Table 4.31. That 50 PSF figure is a distributed load assumption, meaning it assumes weight is spread reasonably and evenly across the floor surface. But here is where the entire calculation breaks down completely with electric vehicles. Your EV does not distribute its load across the whole garage floor. It concentrates thousands of pounds onto 4 tire contact patches, each one roughly the size of your hand. That is called a concentrated point load, and it is the most destructive type of loading a slab-on-grade can experience. When you park a 9,000-pound Hummer EV in your garage, each front tire is delivering approximately 2,300 pounds of force onto a contact area smaller than a sheet of paper. Your 3.5-inch unreinforced slab was never, not even remotely, designed for that scenario. Now let us go one layer deeper, literally, because the slab is only half the equation. What is under the slab matters just as much as the concrete itself. When your home was built, the garage area was typically excavated, backfilled with compacted soil or gravel, and then the slab was poured on top. The quality of that compaction is everything. In expansive clay soil environments, states like Texas, Oklahoma, Missouri, and the Carolinas, the subgrade beneath your garage slab is subject to the same volumetric change that drives foundation movement across the country. During wet seasons, the clay swells upward, creating an upward pressure called heave that can crack your slab from below. During dry seasons, it contracts, creating voids beneath the slab. When a void forms directly beneath a tire contact point and you drive a 5,000-pound EV over it, the slab experiences a concentrated bending moment with zero support underneath. That is a recipe for a full-depth crack or a punching shear failure. Punching shear failure is exactly what it sounds like. The concentrated load from the vehicle punches through the slab rather than distributing across it. Once that happens, you are not looking at a surface crack repair. You are looking at a full slab replacement and a subgrade remediation project, and those are not small numbers. Let me bring this out of the theoretical and into a real forensic investigation I was brought in to evaluate in the Scottsdale, Arizona area in 2023. The homeowner had purchased a GMC Hummer EV, 9,063 pounds, and had been parking it in his 3-car attached garage for approximately 14 months. He first noticed a hairline crack running diagonally across the garage floor about 6 months in. He assumed it was normal shrinkage cracking, the kind most homeowners see in concrete and ignore. He was wrong. By month 14, that crack had widened to nearly a 1/4 inch at its widest point. The adjacent section of slab had dropped approximately 3/8 of an inch relative to the surrounding floor. His garage door threshold had separated from the slab, and most critically, the crack had propagated to the stem wall at the garage-to-house connection, which meant the structural integrity of the entire attached garage framing was now a direct concern. My forensic investigation revealed 3 compounding failure factors. The first was the original slab itself. It had been poured at 3 3/4 inches, just barely above IRC minimum, with welded wire mesh that had not been properly positioned during the pour. It was sitting at the bottom of the slab section rather than centered within it. Wire mesh at the bottom of a slab provides almost no tensile resistance to the top-down bending loads created by vehicle tires. It is essentially decorative at that position. The second factor was the subgrade beneath the affected area. It was a poorly compacted fill zone left over from a pool equipment pad that a previous owner had removed and backfilled without any compaction testing or engineering oversight. Ground-penetrating radar revealed a void approximately 4 inches deep and 3 feet in diameter, sitting directly beneath the primary crack location. The third factor was the Scottsdale soil itself, which had a moderate, expansive clay content, a CL classification on the Unified Soil Classification System that was undergoing seasonal shrink swell cycles and enlarging that void progressively with every weather season. The repair scope for that property included full slab removal and replacement over the affected bay at $11,000, subgrade compaction and polyurethane void filling at $3,200, and stem wall crack repair with epoxy injection at $1,400. Total forensic repair cost, $15,600. For a crack the homeowner thought was normal concrete shrinkage for the first 6 months. So how do you know if your garage is at risk right now? Walk out there today and inspect it with these specific things in mind. Look first for any crack wider than 1/16 of an inch. A hairline crack from concrete curing is normal. A crack you can slide a credit card into is a structural warning. Then look for any vertical displacement across a crack, meaning one side sits higher than the other. Even 1/8 of an inch of differential displacement tells you the slab sections are moving independently, which means your subgrade support has been compromised. Next, look specifically at where your tires sit when the vehicle is parked. Random shrinkage cracks distribute themselves fairly uniformly across a slab. Load-induced cracks originate at the point of stress concentration, right where your tires make contact with the concrete. That is a critical distinction. Then check your garage door threshold and the control joint between your garage slab and your driveway apron. Separation or displacement at those joints indicates the slab is moving as a unified mass, which is a serious finding. Check the perimeter where your slab meets the stem walls. Separation there tells you the slab is heaving or settling, independent of the foundation system around it. And finally, if you have a floor drain in your garage, examine the concrete immediately surrounding the drain casting. Drains create natural weak points in a slab, and load-induced cracking frequently initiates or accelerates around any floor penetration. Now here's what you do about it. Organize by your slab's current condition. If your slab looks good right now with no visible cracking or displacement, the smart proactive move is a slab capacity assessment by a licensed structural engineer, which runs between $300 and $800, combined with a ground-penetrating radar scan to detect any hidden voids beneath the surface before they become catastrophic. If GPR finds voids, polyurethane injection to fill them costs between $1,500 and $3,500 and takes less than a day. That is cheap insurance compared to what comes next. If your slab already has hairline cracking, but no displacement yet, epoxy crack injection stabilizes the existing fractures and restores tensile continuity across the crack plane. Budget $800 to $2,500 for that scope and get the GPR scan done at the same time. If you have visible displacement, sections of slab moving independently, or cracks wider than a quarter inch, you are now in partial slab removal and replacement territory. For a garage intended to house any vehicle over 5,000 pounds, I recommend a minimum replacement specification of 5-inch concrete thickness with number 4 rebar at 12-inch centers on chairs, using a 4,000 psi concrete mix. Budget $8,000 to $14,000 for a single bay replacement at that specification. And if you are building new or doing a complete garage renovation and you already own or plan to purchase an EV, specify a 6-inch slab with 4,000 psi concrete, number 4 rebar at 12-inch centers running both ways, and require a geotechnical subgrade compaction report before the concrete is ever poured. That upgrade over standard IRC minimum construction costs approximately $3,000 to $5,000 more. It is the difference between a garage engineered for the vehicles of 2024 and a garage that was engineered for the vehicles of 1987. The electric vehicle revolution is real, it is accelerating, and it is one of the most significant shifts in residential infrastructure this country has seen in decades. But the residential construction standards supporting it have not caught up. Your garage slab was designed for a world that no longer exists. The vehicles being manufactured and sold today are heavier, denser, and far more concentrated in their load delivery than anything the IRC minimum standards ever anticipated. Do not wait for the crack to widen. Do not wait for the slab section to drop. Get an independent structural engineer to evaluate your garage slab before the damage makes that decision for you. I am Engr. Vance. Protect your structure. Protect your investment.